So as a card-carrying engineer introvert, I certainly have made some exciting career choices that end up getting me up here on this stage today. So wish me luck here. So I'm going to talk to you, I'm going to basically split this into two major sections. We're going to talk to you first tactically about the current release. So we're going to talk to you about 4.5, which just released in August. And then we'll go a little further ranging and look a little bit about what we're doing the next couple of releases out past that. So that's where we're headed with this discussion. So I always like to lead off with the PlantPAx with a modern DCS message. And we call ourselves the modern DCS. I know you've been hearing that for a while now around PlantPAx. It's really the way we deliver a lot of that messaging around the connected enterprise, around the Factory Talk Innovation Suite, about how that actually gets delivered for analytics. A lot of that is really embedded inside the PlantPAx, inside of that modern DCS story that we're telling you about. We call ourselves a disruptor in the market. And primarily, we think we're a disruptor in the market because of the tenets that we bring to the market around DCSs, around the difference between the modern DCS and the traditional legacy DCSs that you're used to seeing out there. We're pretty confident we're on the right path here with the modern DCS message as well, because we started seeing a lot of our competition in the DCS space starting to emulate our story, trying to match up with what we are offering to the market and trying to disrupt and actually disrupting some of their content to make sure they can try to keep up with us and where we're headed. Some other examples around the modern DCS and really around what that's about. Let's talk a little bit about plant-wide automation. So the time when we have disparate control systems in a facility are pretty much over, we think. Having a skid-level controller that can come in with the same technologies, the same control platform that delivers the main DCS platform provides an awful lot of advantages to a system, right? It means that that skid-level controller shares control strategies, shares the HMI content. All of that information that you typically put into those skids now integrates very seamlessly into the main DCS. That's one of the biggest cost points of a system when you're developing it. All these skids are showing up in your facility with disparate control system, and trying to integrate those into your architecture is extremely challenging. If it's a common architecture, so we offer a controller that can run even the smallest little skid, all the way up to the full DCS in a common platform, common programming environment, common tools, common library components on all of that equipment. Means that the operator training doesn't have to be nearly as bad. Right? The operators know how to look at the skids and work on the skids, and the operators know how to repair that content. So maintenance comes in, maintenance knows what a control strategy looks like, they understand how it works. And then the integration of getting those systems to communicate, getting those displays and HMI content up on the main level DCS from the skids becomes extremely easy to do. That's one of the big tenets. Another one I want to talk to you about is something we're calling evergreen technology. So just evergreen, basically keeping your technology current. How many of you out here know about a control system out there that's been running for 20 years, basically untouched, right? Unmodified. You know, you do the basic routine maintenance on it, but the technologies under the hood are pretty much the same as when they were installed 20 years ago. Why aren't people upgrading those systems, right? I mean, the current technology curve over that last 20 years has been huge, right? So all kinds of improvements in analytics and just performance on control systems, data throughput, more intelligent devices. All of those technologies have changed a lot in 20 years, and they really could benefit in that facility, so why aren't they taking advantage of them? And it really comes down to one simple thing. It's really about cost. It's extremely expensive to do that migration, to bring that system forward, because a legacy DCS, oftentimes, to take advantage of new technologies, it's a wholesale upgrade of the architecture. It means you have to touch every component to migrate it forward to the latest technology because everything is so interrelated. With a modern DCS, we have some isolation in that space. What we do is we abstract the individual components of the DCS with a service platform that sort of sits in the middle layer. And that service platform is independent of the rest of the control system around the other infrastructure. So if you want to upgrade a controller, or you want to get the latest technology in controllers, you want to upgrade that historian component, you want to integrate any of that new content, that new technology, it's a simple matter of pulling that one technology out of the infrastructure and replacing it with a new one. And the rest of the infrastructure remains untouched because it's abstracted through that service layer that's in the center there. So what that really means to you is it becomes much more cost-effective to take advantage of new technologies in smaller little segments A new historian comes out with an amazing compression algorithm that has, renders 1 million points in half a second. You want to take advantage of that technology, you can just take the current historian, pull it out, put the new historian in, and the service platform abstracts you from that layer. So that's one of the big benefits that the modern DCS brings to the table as well. So since we're in Philadelphia, I thought it appropriate, the birthplace of the Constitution here, I thought it appropriate to really talk about the tenets of PSUG. So PSUG is really we the people, for the people, by the people kind of event here. We really are here to interact with you. This is really a community of people trying to drive roadmap, trying to drive understanding of where DCS is and where process is actually going to go. So by all means this week, we really need you to engage. This is not an event where Rockwell is just talking to you about technologies. We want you to start interacting with us and tell us where you think the market is going and what's happening in the space. We react to what you tell us at this event. So in this latest release, the 4.5 release, there are several items in this release that are direct results. We actually change our roadmap based on feedback that we get out of this PSUG event. So by all means engage, talk to the presenters, engage in the Ask the Expert sessions for sure. Fill out those surveys on your phones. We really want to get that data from you. Some examples of some of the technologies that we've adopted or changed. We have a PAS-C server now, and what that is, it's a consolidated server. That consolidated server allows you to deliver content throughout the architecture. That PAS-C server basically takes multiple servers and consolidates that down into a single server. So instead of having on a small system where you have 2,000 I/O counts, and instead of having on that small server having to spin up 5 servers, you can now bring that down to a single server and reduce the cost of the installation significantly. And that was direct feedback from this organization that we heard from you guys. So please, please engage this week with us. So 4.5 just shipped in August timeline. It's really got 3 major tenets. It's around smart, productive, and protected. And smart, we're talking about tools to make it so that the system knows better what you're trying to accomplish and shares data between the system more efficiently. Productive is around keeping production available, making sure maintenance is easy on the system and runtime content is very good. And then protected, more around cybersecurity and more granularity on the operational security. So 4.5 just released in August. Let's go a little bit deeper on some of the content that came out in the 4.5 timeline. Some of the smart content, one of the things we released is a common panel. So an I/O panel that you can just order from us directly as a catalog number. What that brings to the table is if you've got a lot of SIs working on a big project or you have facilities across the globe, you can order a common catalog number from Rockwell Automation that's a panel with either 50 or 100 I/O points inside that panel and know that you've got consistency of the install. So operations, maintenance guys, if you need 50 I/O points here or 100 I/O points there, you just order the catalog number from us and you don't have to worry about custom engineering from different SIs or coordinating things with your OEMs. All that content is taken care of from us and you get those panels delivered and you just drop them in place. So that's new in the 4.5. I want to talk to you about historian integration in this release as well. So historian integration is much better. That was one of the things that came out of PSUG last year. Now we have the ability to sniff out throughout the infrastructure all the control strategies in the infrastructure, find those control strategies, identify what elements should be historized in those control strategies for you, and then push those directly into the historian product. And once we do that, that stuff's available in Historian, and it's available also on the PyAsset Framework tool, which gives it context around the area models. So it basically takes all those points, embeds them in Historian for you, and gives you an area model view into all that Historian content automatically by running it through the system. In the productive area, we really worked hard on ISA 101 displays, so our user experience around maintenance, being able to identify problems quickly, operators being able to see that when there's something wrong with their facility. All the new displays are set up with an ISA 101 kind of look and feel. We have new objects, new graphics available for it, as well as new faceplates for the operations to look at that are ISA 101 compliant, as well as a way to actually deploy that content and recommendation how to deploy that content cleanly to follow that ISA model. In the protected area, I want to talk a little bit about the Cisco relationship. So we'll continue to expand that Cisco relationship in the protected area, expanding our network infrastructure or leveraging that Cisco relationship in our Stratix product lines so that we have those network technologies embedded. In the 4.5 release, you'll see more and more content in that space also. Area-based security was also one of the big things in this release around protected, and that really gave us more granularity around what operators or what maintenance people have access to. So we always had role-based security in the past. This gives you the ability to add on top of that the area model, so that now if I'm an operator and I need to work in this specific area, but I have never been trained in area 2, I can get access as an operator as my role, but still have restrictions on where I can actually go into. So much better granularity. You could always do that in the past with our architecture, but now it's built in natively, so it's much easier to deploy and much easier to make that happen. So that was me just touching on 4.5. So that was really just scratching the surface. By all means, go to a lot of the sessions this week. We're going deep on 4.5. The labs have a lot of 4.5. Don't let the minor release version, that 0.5, scare you into thinking this is a small release. This was a fairly large release for PlantPAx. It's as big as any of the releases we've done in the past. A lot of that technology is really big in this release. So I'm going to talk to you now a little bit about the vision, and I'm really going to talk a little bit about what we're actually investing in the next couple of years and what you're going to see coming out from Rockwell in the next few years in the PlantPAx area. Again, continue to lead. We're still going to continue to lead with that modern DCS message, so that connected enterprise, that embedded analytics, that information suite, all of that content is still going to be key to our delivery. But in addition to that, we're going to be focusing a lot of our dollars on things like engineering efficiency. So engineering efficiency, to give you some examples of what we're really talking about here, let's say I have a complicated control strategy that has 300 mouse clicks to actually deploy that control strategy. I know it sounds primitive to use mouse clicks as a measure, but we really are looking at mouse clicks to actually execute on something. So this complicated control strategy needs 300 mouse clicks to deliver, and that means like adding the historian content, getting the alarms right, configuring the alarms, dropping the code in, getting the HMI ready to roll. We've tasked our engineering teams to try to reduce that number of mouse clicks to deploy that control strategy from that 300 to an order of magnitude less. So we're talking, double digits, 30 kind of mouse clicks is what we've tasked them to try to accomplish that with. And that's around getting our systems to share data more seamlessly between the interfaces, making sure that more context is delivered throughout the infrastructure. Much like I talked about the historian integration, you're going to see more and more of that built into the system. So we do a lot of those mouse clicks for you because we intuitively know things that are native to the control strategies and share that information throughout the architecture. That 300 to 30 mouse click discussion, obviously just an example, but that's really not necessarily an initial deployment advantage. Nobody's going to click 300 times 5,000 control strategies on a system, right? So those bulk engineering tools are still going to be there. We're still investing in those bulk engineering tools. But where that mouse click thing really comes into play is over the life cycle of the product. Over 20 years of an installed system, constantly adding, removing, changing control strategies, it drives consistency and reduces that cost of ownership over the life cycle of the product. And that's where that really comes into play, where those bulk generation tools are a lot less efficient. A second area we're going to be investing heavily in the next couple of releases around system complexity. So I talked to you about the past C server that took 5 redundant server pairs and bring that down into 1 redundant server, right, to try to cover those smaller areas. You're going to see us be working on that kind of reduction in other areas as well around the system complexity. So let me talk a little bit about SIP. There's this protocol called SIP, which is it comes out of the Open Device Vendors Association. It's an open protocol. It's not a Rockwell protocol. That protocol is basically the infrastructure on almost everything that Rockwell does. It's how we communicate throughout our infrastructure, all our controllers, IO, our data servers, all of that really talks SIP at the end of the day. And that's on standard unmodified Ethernet. It's a protocol sitting on top of that. One of the cool things that SIP brings to the table, it allows us to open a connection from a controller to a data server, for example, and use that pipe to do what we call a report by exception technology. And that means instead of just pushing data through that pipe every half a second to make sure the data is fresh, the control system is now smart enough to push data only when it's relevant to the top end. So we can actually analyze that data, understand whether it's relevant, whether it's changed enough or it has relevance to the upper level systems when it changes, and then push it through that pipe automatically. kind of a tactical what that really means to you and why you would care. We did an analysis on a large system we did today, a 20,000 IO count solution. And today, to support the data needs of that 20,000 IO count large system, we needed 10 redundant data server pairs up there to make that actually deliver the content to the analytics, to the historian, to the data, to the HMIs. We needed 10 redundant server pairs. We think once we implement this report by exception technology, we should be down to closer to 3 redundant server pairs in that architecture. So the cost to you of spinning up those servers, the long-range maintenance cost on maintaining 10 servers as opposed to 3 is significantly better, right? And the complexity of getting those servers to talk to each other when you have 10 redundant pairs is also, significantly reduced. And a lot of the stuff we talked to you about earlier this morning was all about data volumes, exponentially increasing. We think we need to adopt this technology just to survive, right? We can't keep expanding that server count exponentially along with the data. So we're becoming a lot more efficient at how we deliver data through that pipe up to the control system. So those are some of the big investments that we're going to be working on in the next couple of years with PlantPAx releases. Now let's look a little bit farther out and look a little bit more at maybe a 10-year vision. So this isn't really tactical. This really is talking about where we think the market is actually going long term. Everybody knows about the Purdue model, right? We've had this Purdue model for 15, 20 years out there, that layer 1, layer 2, layer 3 model where you have I/O at the bottom layer, you have controllers above that, some MES content, the cloud-based stuff at the very top of that model. I think that model is going to get a massive overhaul in the next 10 years. You're going to see that relevance of that model sort of fading out of favor in lieu of pressures on the market that are actually forcing that model to change. Some trends that I see making that happen, edge computing is a big one. Driving more intelligence into the instrumentation, more intelligence into the control system as the horsepower goes up on those low-end devices. You're going to see us moving more of that content out of the middle layer of that Purdue model down lower into that lower edge-based computing. And Rockwell's already on that journey. We have this model predictive control module that basically used to be a massive server in the cloud that now rides on a module down at that edge. Historian ME module, we have a historian product that basically used to be a server and now lives down in that lower edge. Windows machines, Linux machines, all of that content running on different cores in the processor are also in our current roadmap and our actual available portfolio now. And I think you're going to continue to see that migration as more things start moving down that edge. By the same token, you're going to see pressure going the other direction. Cloud-based computing, cloud-based content is just huge for our market. The advantage of that cloud-based content with the unlimited horsepower, the amazing data storage capacity of that cloud-based content is just extremely attractive. What it really brings to the table is also just improved maintenance of the system. Instead of having the facility have to manage operating systems and patching and all of that content on that analytics and on that actually control solutions, you're going to see more of that content migrating up to the cloud. So that becomes the responsibility of a vendor like Rockwell that provides that cloud service to make sure we maintain that operating system, maintain those patches in that system for you because it's up in the cloud. Certainly we understand there's challenges there, there's security challenges, there's network resilience, there's reliability that we know we're going to have to address moving forward, but we really think the trends are actually drifting to split that Purdue model into multiple directions to make that move forward. And this is a journey, this is a data journey. This is not going to be an overnight kind of a switch. This is going to take years for this to happen, and Rockwell is going to work very hard to preserve your current investment. It's not like this is going to be an investment that we are going to suddenly come to you and say, hey, here's this new model. We're going to migrate your content forward. Your investments in your current solutions are going to continue to live on and move forward. So by all means at PSUG this week, please engage with us. If you don't agree with this concepts or any of the stuff we're talking about, talk to me, talk to the rest of the team, talk to people at Rockwell, talk amongst yourselves about this concepts of where we're going and what we think the market's doing. That's what PSUG is all about, is keeping you guys engaged, and we're really a big community about driving our developments forward.